Can I begin? All right. Okay. Yeah, hi, everyone. I'm going to give a talk on the topic of rollup is all you need. I'm from ZKM. I'm the chief scientist of Project ZKM, where we build a ZK VM for the architecture of MIPS. So in building a lot of inter-chain, cross-chain communication, we're using bridges. But bridge has a lot of problems. So we're thinking of building something transcending bridges. So the question we're facing is to bridge or not to bridge. And we have a different solution. We're using rollups in place of bridges. The premise is that you have to think of no bridges. To do cross-chain communication without bridges, that is basically kind of thing we're building. To think about this problem, bridges, people are kind of claiming a lot of things that bridge actually are not. For example, the idea of trusted bridges. But you can't trust bridges. So trusted bridges is misnomer. To think this, we can see from like trilemma point of view. It's called trilemma. So three aspects of bridges, from operation, security, and custody. It's the problems the bridgings are facing. And we're trying to solve these problems better than bridges. So actually, as I said earlier, trusted bridges are actually a misnomer, but we can also see it as a holy grail that bridges are fighting to achieve. But by holy grail, I mean we're not there yet, and probably never, right? So from an operation point of view, they have to be as good as the underlying blockchain, which is not, because bridges are not blockchains. They're their own entity. So we have to remember that. So a bridge between, for example, Bitcoin and Ethereum. So it's neither. It's not part of the consensus of Bitcoin. It's also not part of the consensus of Ethereum. It's not part of consensus of either the source or the destination blockchain. Also, bridges are kind of wrapping all the transactions in their own way. And ideally, you want to using smart contracts on the blockchains to carry your transaction. But we're not. Bridges actually are not doing that. The custody, right? You have to trust the bridge. You have to give your money assets to the bridge owner, which is a big no-no. Ideally, it should be self-custody, which they're not. So the holy grail of trusted bridges, if you can do it, you need to, using smart contracts for decentralized system for the operation, your security should be as same as the underlying blockchains you're trying to connect. And in terms of custody, you should be self-custody. Think for a minute, can current bridges ever do that? Probably not, right? So in order to design, we have to see the design criteria to reach those points. We can think in a distributed area, like we're very fond of the idea of a trilemma. So let's see these three requirements in terms of trilemma. So we can see this as to be there, you have to have instant guaranteed finality, right? The cross-chain communication predicates on something called a atomic transaction. But we all know different blockchains have different finality. They don't even agree. Many of them would actually not have this instant finality in their design. So how do you guarantee that, right? That's one challenge. And also, like I said earlier, bridges are neither in the source or in consensus with either the source or the destination blockchain. So they see assets in a totally different way. They're not connected to any assets. In order for them to be seamlessly connecting each other, you need to see the asset in the same way. So that's the unified liquidity comes in, right? The bridge doesn't really in the consensus with, for example, Bitcoin or Ethereum. It's its own thing, right? So you need a single liquidity pool for all the assets. So they see this on the same terms. And then there's the native assets. So to be as secure as the underlying blockchain, it's best that you be able to transfer native assets, which I think bridges will never be able to do. Then to actually move a level higher, right? On top of these assets or financial assets or like coins, tokens, we can think of this as a general interoperability, trilemma, because this way, if you find a solution as powerful as a trusted bridge, you can actually go beyond all those limitations of just transfer assets. You can execute very complex, complicated, and powerful computation. So in that way, we can kind of just level this up with the trustlessness of security guarantee as the underlying blockchain for anything, and not just financial transactions. Extensibility, meaning like one liquidity pool for all assets, whatever you design your assets be. It could be like a gaming assets or assets like for social goods, for things beyond the financial assets. Assets defined on some contracts, smart contracts, or even real time, for example, AI, right? Generalizability, meaning like the assets for target blockchain to get to the source blockchain, it's the same assets. The bridge shouldn't be sitting in between and just get away with whatever like schemes they can concoct with. I would like to add that basically you can just see any bridge as being able to drug. So bridge equals to rug. A little bit extreme, but that's basically what bridges security assumptions are. They can rug any time. Doesn't matter their reputation, right? They can, then they'll do it. Okay, so now enters our solution, which is we use rollups, right? Rollup is all you need. So rollups themselves are bridges, but they're very secure bridges. And the rollups are trustless and naturally decentralized, and they're verifiable. And they support native tokens, right? This is something that a cross-chain bridge will never be, right? So on rollups, ETH is the real ETH, right? All right. And but they're not normal bridges. Rollups are not horizontal bridges. They're not cross-chain bridges. They're vertical. They're actually for one blockchain. So in order for this thing to be able to do cross-chain, we have to kind of create something we call entanglement, right? Like in the quantum entanglement sense. What do we mean by this? So meaning that you can magically pass any message state changes horizontally without adding any security assumptions. What do we mean by that? Meaning that you basically can't send the information over. If you can send the information across chain, that's a bridge. So in order for us to say there's no bridge, we can't send any message cross chain, right? Okay, then how do you do send bridge cross chain, right?
Unfortunately, we're gonna have to.
So the assumption is that each L2 will rely on something called a ZKVM. So in our case, we're building ZK MIPS, and they have shared sequencers. Well, they can be only one sequencer as well, because the security is on layer 1. Okay, because time constraint, I'll just kind of just lay out what this is, and I'll give you analogies so you understand this technology. So for entangled rollup, on the left, these are just normal rollups, right? This is one rollup for one layer 1 chain, and there's another one, right? They're not entangled. So for them to be entangled, means that you mix them together, right? And you won't see any cross-chain links here. So no cross-chain. You never do cross-chain. But if you just kind of entangle them like this, it won't work, right? Many people actually thought about this, but this is not enough. Because like I said, blockchains are different siloed entities, right? So the assets in one blockchain doesn't really mean anything. Ethereum doesn't know what Bitcoin is. Bitcoin doesn't really know what Ethereum is. So just do this is not enough. Okay, so what we do is that we entangle them using ZKM, and we have something, a mechanism, a device called shadow contract. I'll give you an example. I'll give you an analogy to understand what shadow contract is. So this is basically how entangle rollup is done, and you can see there's no cross-chain links whatsoever. So there's no horizontal cross. So we don't send messages over cross-chain like normal bridges do, right? Everything will be done by the entanglement here. All right, so this is an example how this works.
I think we have to wrap it up there, unfortunately. We've really overeaten up into our time there. Thank you very much.
Just follow us at Project ZKM, which is zkm.io. You'll find everything.
Fantastic
presentation.
Thank you very much.
Yeah.